Okay, as I was saying, the past few days we've been learning set notation. Alright, we know how to read and interpret, but for today, we need to put it into diagrams. Okay, when all these mathematical notation are put into diagrams, we call them Venn diagram. So, Venn diagrams are usually inside a rectangular box. A square is fine, but it's easier to draw a rectangular box. And on the top left-hand corner, please usually write down the universal set. That's why the Venn diagram in a rectangle, that is the biggest set already. Out of these three, alright, it's very obvious A and B do not have any relationship, set A and B. But, okay, for the first one, no relationship. But there's a way to write no relationship. That one we will learn later, okay? Either later or tomorrow, eh? But notice, in this particular one, A and B overlaps. So when they overlap, oh, they have some common elements. Okay, the most interesting one, and this is the one that's very popular as well. Okay, this last one, you can see the set A entirely inside set B. That means all the elements in A are inside B. So we can say A is a proper subset of B. Okay, based on what we learned the past few days. The universal set is given. Alright, there's also set P and set Q. You are supposed to represent this inside a Venn diagram. Take note, inside a Venn diagram, you must be as comprehensive as possible. Every Venn diagram is around 2 marks. Unless it's more complicated, they may give 3 marks. Like I said earlier on, all Venn diagram must be represented by what first? Universal set. What shape? Rectangle. So please draw a rectangle that's big enough first. Okay, so you have to draw a rectangle and indicate with a universal set sign, the epsilon at the top left-hand corner outside the box. Next, we need to insert all the diagram first. But before I do that, there's something I want you to take note. I need to identify the elements first. See whether there are anything common first. Let's take a look. What are the two sets inside? P and Q. Are there any common elements inside P and Q? What are the common elements for P and Q? E. What else? D, yeah? Okay, so this must means that A, it must be the diagram that overlaps. You agree? Because they have common element. So I'm going to start drawing now. See how I draw? So I draw 2 circles. One is called P, one is called Q. I start with the common elements first. You told me D and E are common. Let me put it in. D, E. One important thing. We are not listing out an element in the set. Inside a Venn diagram, do not put comma. Never put comma. Alright, just leave space. Okay? Okay, I input D and E. What is missing inside P? A and F, right? So let me put in A and F. Is there anything missing inside Q? Yes, there's a set. There's an element B. Do you think this is sufficient? Why not? The universal set is bigger. There are elements in a universal set not found in P and Q. Am I right? Let's check. Is A done? Yes. B done? Yes. Is C inside already? No. Then you need to draw outside the circle. D is done. E is done. F is done. G and H. Okay, notice I use 2 different styles to write the elements. One way, I can write on top below. Inside the circle, do you see me writing on top below? Because I got a lot of space, ma. But when you don't have a lot of space, it's okay to write across. But leave space in between. Do not write comma. This is what a Venn diagram looks like. Okay, like what Le Ya say about this question, yes, you can solve A and B, you can list out the elements. But it's not correct because, take note, the universal set is the biggest set. Inside the universal set, you can only see integers and whole numbers. That is why, how come set A has a 0.5? Even though you solve is 0.5, you cannot include. So, please erase off. Okay, now. Okay, this is what I always observe over the years. Many students, the first thing they do in Venn diagram, they draw two overlapping circles. I agree, because a lot of questions are like that. Okay, so you see, 3 is inside A and B. Then you write like that. Alright? A, B. Oh, B also have element 0. Okay, then you fill in the rest of the numbers over here. But what do you notice if I draw the Venn diagram like that? There's an empty space down here. What? If there's empty space, what does it mean? Are there any element? So this diagram is wrong. What can be a better diagram? Incomplete. Yes, exactly. Because the element for set A only has 3. A is a proper subset of set B. Remember the third kind of diagram I introduced at the start? So when you have an element completely, or rather a set being a proper subset of another set, you must draw a small circle followed by a bigger circle. Okay? And the 3 examples I've shown you today illustrate the 3 different kinds of relationship. Like that, can or not? Cannot. What is missing? B. I write already. The rest of the elements right outside. But this one like not a lot of space. I write vertically also can. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I write comma? Cannot.